Hey guys, welcome back. We are going to verify inverses now. We are going to prove that two functions that were given, okay, they could be just, if you're given a function f of x and then you're given a function g of x, we're going to prove that this function and this function are inverses of each other, okay, essentially opposites of each other. All right, there are two steps to verifying inverses. Step one, we are going to find f of g of x. Okay, a lot of parentheses in there. All that means is we're going to plug g of x into f. Okay, think of like little Russian nesting dolls. We're going to plug one doll into another. And step two, we're going to find g of f of x. We're going to go the other way around. We're going to plug f into g. Okay. When we do this, if your functions are truly inverses, the composites, that's what it is when you plug one function into another function, f of g of x and g of f of x will both simplify down to just x. Okay? The most complicated part of this whole process is just making sure that you know your algebra. Okay? So we're going to take a look at this first example, a little bit of a mild example. Okay, we are given f of x is equal to 3x plus 4. We are given g of x is equal to 1/3 times x minus 4. Okay, so the first thing we're going to do, step one, we're going to find f of g of x. Okay, so that's the first thing I'm going to write. I'm going to write f of g of x. Okay, that means that we're going to plug g of x into f. Okay, this is our g of x. So everywhere we see an x, okay, and I'm going to start off like this. Everywhere we see an x, which would be right here, we're going to plug in g of x, which in this case is 1/3 times x minus 4. Okay, so I'm just gonna rewrite this. F of, instead of g of x, I'm gonna write what g of x is. It is 1/3 times, I'm gonna do this in a different color so you can really see what the difference is. 1/3 x minus 4. Okay, so everywhere I see an x in f, I'm going to plug in 1/3 times x minus 4. Okay, so this is my f of x. All right, so I'm going to copy everything that is not an x. So I see a 3, I'm going to write a 3, and then I see an x. So instead of an x, I'm going to put a big old parenthesis, and I'm going to copy what's here. So I'm going to plug in 1/3 times x minus 4. Close that parenthesis, plus 4. So I replaced my x with g of x. That's you plugging one function into another function. Okay. Now all you're going to do is simplify and clean everything up. Okay. So we're going to use our algebra. So the first thing I'm going to do is I'm going to think about PEMDAS. So first thing I'm going to do is parenthesis. Well, I have this part in parentheses. Okay. I can't really simplify this any, but what I can do is I can do the multiplication because there are no exponents. And I'm going to multiply 3 times 1/3. Okay. So any number times its reciprocal is 1. If I were to write this sidebar out here, if I were to do 3/1 times 1/3, that equals 3 times 1 is 3, 1 times 3 is 3, so it equals 1. So anytime you have a number times its reciprocal, it's flipped fraction, it equals 1. So 3 times 1/3 is just 1 times x minus 4 plus 4. So now I got rid of my parentheses just by multiplying these two pieces together, okay? And then last but not least, 1 times anything is just itself. So then I just have x minus 4 plus 4, and you have negative 4 plus 4. Those cancel each other out. They become 0, and we're left with just x. That's what we want. We wanted it to simplify down to x, okay? So let's do the opposite of that now, all right? So the other half of this is we have to find g of f of x. So we have to go the other way around. First we plugged g into f. Now we're going to plug f into g, okay? Again, I'm going to write my g function so that I know that everywhere I see an x, I'm going to plug in f. So there's my x, okay? I'm going to plug f of x in where I see that x. Well, what is f of x? I'm going to have g of f of x is 3x plus 4. So this is what I'm going to replace my x's with. Okay? So start off, I'm going to copy 1/3, open a parenthesis, and then I see an x. So I'm going to open another parenthesis, and I'm going to plug in 3x plus 4, close that parenthesis, minus 4, close big parenthesis. Okay? I replaced my x with g of x, with f of x. Okay? Now I get to do cleanup. All right? PEMDAS, I have to do parentheses first. Well, my innermost parentheses, 3x plus 4, I cannot simplify, but 3x plus 4 minus 4, I can absolutely do that. I have this plus 4 minus 4 here. Those cancel because they are 0, and you end up with 1/3 times 3x. Again, we have the same situation that we had over here where we're multiplying a number times its reciprocal. 3 over 1, 1/3. So those also end up canceling out and becoming 1 when you multiply them together. So we'd have 1 times x, which simplifies down to just x. Check. Now we have proven that 3x plus 4, f of x, and 1/3 times x minus 4 are inverses of each other. When we simplified down, they came to x. Okay? It's a matter of plugging each function into the other one and simplify. All right? Let's take a look at a slightly more complicated one. Again, more complicated just means that you might have some more operations that you are doing. Okay? So start off with step 1. I'm going to find f of g of x. That means everywhere I see an x in f, I'm going to replace it with g of x. So f of x is x cubed minus 8. This is the x I'm going to replace. What am I going to replace it with? Well, I'm going to replace it with g of x. G of x is the cube root of x plus 8. So again, start off, I see an x first, so the first thing I'm going to do is I'm going to put the cube root of x plus 8 cubed. I replaced this x with my g of x. And then subtract 8. Okay. Order of operations. Parentheses, I can't do anything more in here, so I can't do anything more with the parentheses. Exponents, though. I have the cube root to the 3rd power. Those two are opposites, are inverses of each other. So what we're going to do is they cancel each other out. So this cancels out with the power. A root can cancel out a power. Then we're left with just x plus 8 minus 8. Again, 8 minus 8 is 0, and those cancel each other out, and you're left with just x. That's what we want. Remember, if we simplify all the way down to x, we know we've got our answer, okay? So that's half of it. We have to do the other half. We have to do g of f of x, okay? So we plugged g into f. Now we're going to plug f into g. Once again, remember, this is what we're replacing the x's with, okay? So g of x is the cube root of x plus 8. This is what I have to replace. What am I going to replace it with? I'm going to replace it with f of x, which in this case is x cubed minus 8. So everywhere I see that x right here, I'm going to replace it with the x cubed minus 8. So I'm going to start off with the cube root of an x. So instead of that, I'm going to write x cubed minus 8 plus 8. Clean up as much as we can. And I'll have minus 8 plus 8 first. Those cancel out to be 0. And I'm left with the cube root of x cubed. Again, those two things are inverses of each other, a cube root and a cube. So that would also cancel out. And you are left with just an x, which is also what we want. Okay. There are more complicated problems. I can definitely show those if you like, but this is your basic start off of how you would verify that two things are inverses of each other. You have to plug one function into the first, and then plug the first function into the second. And when you simplify down using your algebra, you should get to x each time. If you don't get to x, that means that they are not inverses of each other. All right? Let me know if you guys have any questions. If you have a specific example, send me a message, write me a comment, and I'll be happy to make a video about it. All right? Have a great day, guys. I'll see you guys in class.